So we had the title slide on solving the Agile estimating conundrum with something called SiSE. Now, SiSE is an initiative of the Department of Homeland Security in the United States, who has their cost estimation division, cost analysis division. So before we get into it, I really want to set the stage to what we're talking about estimation of Agile programs. I know that there are initiatives and thoughts underway and people saying, you know what, we don't need any estimates, and estimates are always going to be wrong. And estimates, we don't need those in an Agile environment because we don't know the scope. And I've heard it all. I recently came off of a contract as the lead author for the Software Cost Estimation Body of Knowledge for the International Cost Estimation and Analysis Association, ICEA, where we pulled together a lot of disparate information around the world to formulate a body of knowledge on software cost estimation. So what we're talking about, when I'm talking about software estimation, I'm talking about software development effort estimating. And you may say, look, we're in an Agile environment. We don't need that. Well, if you want to have funding, if you're in a governmental organization, if you're in a large program, anything like that, you need to have the funding. And one of the important things that you may have heard of from the chaos group or the chaos reports from the Standish group, or from even the little video that Susan played previously, projects are bound to fail in software development. That's kind of a given. Agile has improved that. However, two of the major reasons for so-called project failure are over budget and behind schedule. Well, let's trace that back. How do you end up over budget? Well, you end up over budget primarily because when you start out with a budget that is inappropriate, that is way too low. And I'd like to challenge you, if you are an Agile software developer, rather than rejecting the idea of having estimates, provide the information that would be needed to software cost estimators. Provide them with all the realistic information about the project or the program that you're going to be developing. Give them that information so that they can prepare an accurate, realistic, historical-based estimate and get the levels of funding that will make these successful. Let me give you an example. If I said to you, I need a hospital built. And you come back to me and you said, well, we've done all the analysis and we think it should take a year and a half, 18 months to build a hospital of such and such a size. And I say, oh, that's ridiculous. Get it built in a month. You'd look and you'd say, that's unrealistic. We're not going to write a contract for a 1 month building of a hospital. Well, what happens in software development oftentimes is we end up with these unrealistic estimates that are way too low because the software cost estimators have not been exposed to the things that are going on, and history will repeat itself where we end up with low estimates of the cost. It's incumbent on you as a software developer or a Scrum Master to be able to provide the input to those software cost estimators to do a better job. Realistic funding is going to result in realistic and better managed projects. And the second problem we have is that the schedule typically is too short. Again, how do we end up exceeding schedule? Well, if the schedule in the first place is inappropriate and unrealistic, that's a problem. Large government departments, even if they are Agile or hybrid Agile, even if they start out with a traditional type of ConOps or concept of operations, which they have to, no government department is going to simply write a check for, say, $6 million and say, go at it. Go have an Agile time and bring me something back. No, there has to be an estimate. What justifies that $6 million? So there's really four major puzzle pieces that happen in software cost estimation. And again, when I'm talking about software cost estimation, I'm talking about figuring out the cost of the software development piece, not the systems piece. That would need to be added on for a lifecycle cost estimate or for a program estimate, not the system integration, not the ERP planning piece, I'm talking about a custom software development. So let's take a look just at that. And that's really where our Agile teams are working. So the challenge for us within the Department of Homeland Security and the impetus behind SiSE was that there's this challenge on how do you create realistic software size-based cost estimates for Agile software development from a high-level product backlog. And within the federal government in the United States and within many federal governments throughout the world, there's a process whereby you need to have an estimate of the software development cost way, way, way up front. Now, if you've been involved in software development for any length of time, you know about the cone of uncertainty. That if we don't have solid requirements, it's very difficult, but we need to have some basis on which to have an estimate because we're doing funding and appropriations typically 2 to 3 years in advance. So we've got to have something. We've got the Agile Scrum process, which doesn't matter if you're using Scrum or Kanban, or we've got an Agile Scrum process, and then we've got these appropriation or acquisition timelines, and we need to be able to work within those. So to say, yeah, we don't need no stinking estimates, that just does not fly, and that will not work. We need estimates, but we need to have accurate, realistic, and reasonable estimates. So how do we get to that? So prerequisites for a realistic software development. Well, we need to start out with a current program information. Where are we at today? What are we going to be actually estimating? We need to know the scope and the purpose of doing your estimate. We need to know how complex is this software going to be? What are the capabilities of the development team? There's a lot of pieces that we need to know. What's the program data? Is it going to be a new development or an enhancement? Is it going to be COTS? Is it going to be, what's the language we're going to use? Because if we're using COBOL versus .NET versus Java, that changes the cost. What's the platform? Is it going to be a multi-tiered architecture? What are we looking at? And one of the challenges, one of the most elusive challenges, is having an estimated size of the release or the product backlog in standard units of measure, either source lines of code or function points or something like that. So that's the first puzzle piece that we need to get our hands on to do a cost estimate. The second piece is we need some sort of historical program data. If I say, how much will it cost to build this piece of software, and I've never, ever, ever done it before, then I'm going to have to rely on some sort of expert judgment. But the best estimates are going to be historical program-based estimates, where we've got data that is comparable and normalized that we can look at and say, okay, how can we do an estimate based on what we realistically know it took to deliver that in the past? So when we look at historical program data, we need to take a look at the scope of it. We need to take a look at the complexity of the software and line it up and make sure it's similar to what we're estimating. We need to take a look at the program data, whether it's new development or enhancement, because building a brand new system versus enhancing a legacy system are two different animals. We need to know whether or not we're using COTS, because COTS is kind of like if you considered building a house, we're bringing in a prefab kit, or we're bringing in a mobile home or something to build that square footage. We need to know the programming language because we don't want to line up historical data that's in .NET with a new development project that might be in Java. We want to look at the platforms. We want to line the projects up so that if we're looking at historical data as a basis for our current program estimates, they're lined up and they're normalized. We want to take a look at the software size and standard units of measure. And you want to make sure that your historical units of measure are going to be similar to the ones that we're using today. And then we take a look at the effort that it actually took to build that piece of software that we've got in our historical database in terms of the effort in standard units of measure, either hours or in some cases per sprint. So we also need, if we're going to do a cost estimate, which is the step 3, once we've got our size, and we've got historical data, now we can start taking a look at how do we come up with a cost estimate. Well, we've got an estimated size in terms of our current program. We've got our effort, and an effort equation, or what's often called a CER, or cost estimating relationship, is usually size to an exponent times throughput. And then our cost, once we've got our effort based on our size of our program or our software that we're doing multiplied by the throughput. Throughput comes from our historical data. Cost is simply effort then times the labor rate. And then schedule or duration is going to be effort times the full-time equivalent team size divided by hours per person month. That's just the easy way of looking at it. So we need to have an estimated functional size of our product backlog from the current program information. We can then take a look at our historical data and in terms of throughput, effort per unit of size, and then we come up with an estimated program effort. So our biggest challenge, and really the impetus behind SiSE, is coming up with an estimated functional size of our product backlog. So this is where SiSE came in, and SiSE, S-I-S-E, stands for Simplified Software Estimation. And SiSE approximates the size of a software development effort for use in estimating our effort, our labor, our cost, and our schedule. It's been developed over 5 years of research by the Cost Analysis Division, CAD, at the U.S. Department of Homeland Security, in conjunction with a number of other federal departments. And SiSE has now been released as an open source handbook and a Microsoft Excel template. And that's available for download. And the handbook, it has a lot of different information in it. So today I wanted to spend a little bit of time going over what does SiSE actually mean? What could it help you as an Agile software development program manager? How could it help you do a better job of software estimation? So why was SiSE even needed? Let's talk about that for a minute. Well, software size, the size of the software you're building, is proven to be the major cost driver of software development. And if you need some research behind that, there was a recent Government Accountability Office, GAO, handbook produced by GAO in the United States, and it's available for download. There's also an Agile guide that was just produced, and both of those were developed in 2021. So software size is proven to be the major cost driver of software development. And traditional Agile measures are difficult to use in software estimation. So without offending anybody, Agile velocity in terms of story points delivered per sprint is absolutely team specific, because we don't have a standard or an ISO standard for story points. It's based on 2 non-standard variables. Well, the size and story points is team specific. We can't use story points across teams or between teams. It's a relative effort value for completed user stories. So if I haven't completed a user story in terms of delivery, it goes back on the backlog and I get 0 story points for that sprint. So the size and story points is only what has been delivered, and that can be an issue. And then the idea of per sprint. What is a per sprint? How many hours are in a sprint? And I realize that absolutely a sprint is a fixed time boxed 2 or 3 week typically amount of time. But within that, my 2 to 3 week calendar amount of time, I could have vacation days or national holidays, or I could be putting in operations. There's a lot of different things. So when you say per sprint, it's kind of like saying per project. My person hours per sprint can vary by the number of calendar days that people are actually working, the FTE team size that goes into it. So Agile velocity is not very valuable for a software cost estimator who needs to come up with a program cost or a program size or a program effort and schedule, which you absolutely need for federal acquisitions and appropriations. Functional size measurement, if we're actually doing the measurement per se, using if-pug function points or another ISO standardized method, requires details that we just don't have available when we're estimating a program. So these were kind of the challenges that came up in terms of what do? We need to have a better way of doing software cost estimation, especially on Agile type projects, where we start off with only in some cases a ConOps, which means concept of operations. So SiSE can be used with ConOps or user stories to consistently and reliably estimate the functional size in simple function point units for Agile software development. So I'm going to explain to you what actually goes into SiSE and what's behind it. So the SiSE process to estimate functional size. We start out with a project vision statement. That's some sort of high-level functionality. So what do we have? If you look below the top rectangle, we have high-level functional requirements. Well, from that, we typically end up with a prioritized project backlog of user stories. And user stories can be, and I know user stories originally were supposed to only be functional user requirements that could fit on a 3x5-inch index card and describe simply a piece of functionality. I've reviewed thousands of user stories. And the user stories today, especially if they're taken from Jira or they're taken as tasks, proxied as user stories, can be functional, they can be non-functional, they can be fixes or spikes, or they can also be user stories written up as a developer, I want to blah, 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 or as a tester, I want to. So we've got this whole huge mix in terms of a product backlog. We want to take a look purely at the size of the functional user requirements, which is kind of akin to taking a look at a floor plan if you were building a house. So I've got a very sketchy floor plan. Sure, I know that I need to have a building code that is kind of like its insulation and where I'm building it and, you know, hurricane-proof windows and things like that. But if I'm taking a look purely at the size of the floor plan, that's akin to taking a look at the functional user requirements for software. So taking those functional user stories, given the high-level functional requirements, I can break those into business functions, and I can identify some stakeholder groups. So from this, we take our functional user stories. As a user, I want to do some sort of function so that I can obtain some sort of outcome. Well, when we break that down from a functional standpoint of measurement or of estimation, we look at the transactional functions. What are the types of things that as some type of user, I want to do some sort of function? Well, the functions can be transactional. They're things like create, delete, update, read, report, amalgamate, populate. Those types of verbs are typically within our functional user stories. We're also going to have logical data groupings, things like saves. As a user, I want to create user accounts so that I can manage my users. So in that case, I've got a verb that says create. I've got a save that says user accounts. From a stakeholder group perspective, we've also got interfaces with other systems or agencies, and this is very typical on large federal programs. So then what does SiSE do? Now that I've got my functional user stories, SiSE says, hang on, we can have verb keywords. What generally happens if I see the word create in a functionality? What does that typically break out into? So if I say, as a system administrator, I want to create user accounts so that users can sign in. Okay, what does create typically mean? Well, create means I'm going to be storing user accounts. I'm typically going to add and view and store. So in that case, the word create typically means two functions plus a data group. And I can go through very, very quickly then by having keywords associated with patterns. So we've created this SiSE template that generates transactional and data functions and derives an estimated simple function point size. So the SiSE template generates a functional size estimate in units of simple function points. And we've taken a lexicon of about 140 verb keyword patterns together with about 300 synonyms so that you can very quickly and easily, without a ton of function point knowledge, go through and come up with an estimated functional size. And to me, this is really exciting. This is really powerful to be able to go through a Agile backlog, a product backlog, and quickly be able to ascertain an estimate of functional size that we can then turn into an effort estimate that can then be turned into a cost and schedule estimate. So when we were taking a look, and the Department of Homeland Security, and I'm on their development team, so I'm not the person doing all of it, but I'm on their development team, and they had chosen the software sizing units of measure before I got involved. But they really looked at 3 different types of measures that could be used. So source lines of code or effective source lines of code. Well, yeah, they're an objective size measurement. They're good for high-level RUM analogy estimates. They're fairly easy to collect after the development has been finished. So we've got a lot of data available that's slot-based, but it's highly dependent on coding language and the skill of the programmer. So that was kind of set aside as being useful for some things, but not the prime opportune choice for doing estimating upfront. Well, story points, as I mentioned, are a subjective size measure, and I understand that. I know the people from the Agile Manifesto. I know where story points originated and where they came from and who recommended them and what they're, and they're valuable. They're absolutely valuable if you're managing your program and you're comparing what you did before to what you did on the previous project or what you're going to be doing in the future. Yes, velocity has its place, but velocity does not work well for overall project funding at a high level. When I need that 2 or 3 years in advance and I've only got a high-level project backlog or product backlog, velocity is not going to help me. So I'm not discounting velocity as being useful when you're working on the project itself, but for development of software cost estimates that are going to stand up against historical data and be based on historical data and be presented to Congress or governmental departments, they just don't work. So we can't independently estimate or analyze these, and we can't do that beyond a single team level. So story points were kind of set aside as well. So then we take a look at function points or simple function points. Well, they're an objective size measure. There are ISO standards. It's a standard unit of measure. We can compare across programs. It doesn't matter what your program is, your square feet or your function point size is going to be consistent in terms of how they're measured. It's a long-term view at a program level, can be independently estimated and analyzed. So the SiSE first choice was really to take a look at using function points or simple function points. Functional size, if you don't know anything about functional size, I'd like to just real high level introduce you to something called the International Function Point User Group, or IFPUG, Function Points version 4.3.1. When I talk about functional requirements answer the question, what does the software do? Not how good does the software have to be, but what does or what will the software do in terms of functionality, in terms of work processes. So we draw an application boundary around the functionality that is provided by the piece of software. And using the IFPUG approach, we take a look at things called external inputs, which are functionality that sends data across the boundary, and it comes from a user. It can come from another piece of hardware, a piece of software. It's data that enters my system and causes an update in an internal logical file, which is really a persistent logical entity about which I'm collecting data. Now, the word user, when we're talking about user, we mean any person, thing, other application, anything that exists outside the boundary. And it's akin to a object-oriented actor. So anything that can send or receive data is considered to be a user. So when we're talking about functional user requirements, it doesn't need to be a physical, living, breathing person. We're talking about a user as being similar to an actor. So we've got external inputs, which send data across my boundary. We've got external outputs, which is a provision of data that typically contains some sort of a calculation or some sort of a derivation of data. And then we've got external queries, which are typically our displays and our screens and our retrievals of data. We've got external interface files that are counted, which are any data that exists outside my system that I just reference. So if I'm looking to see whether or not your calendar is free for a meeting, I'm just doing a reference of that. I can't update it, but I can just look at that. So that would be an external interface file. And then we send and receive data from other applications. So the ifpug function point method requires you to go through your functional requirements and categorize them into one of three transactional functions, inputs, outputs, or queries, and then to identify all data as either belonging to an internal logical file, which are those entities that we maintain, or those ones that exist outside. The next step, once you've identified those, is you have to take a look and say, is it low, average, or high? And a certain number of function points is assigned. Well, if you're early, if we're working with a ConOps, a concept of operations document, or a system requirements document, or Epic, or user stories, or any of that, we don't know those things. So doing an ifpug function point count or estimate, that just isn't going to work. So ifpug has recently acquired the simple function point methodology, which was developed actually in Italy and has now been taken under the International Function Point Users Group and was codified and standardized into a method now called Simple Function Point version 2.1. Simple Function Point says, you know what? We can't necessarily tell if a transactional function is an input or an output or a query based on, we don't exactly know what its primary intent is. We just know that we're going to have functions. And Simple Function Point says, we don't care what kind of functions it is. If it's an elementary process, an elementary unit of work, we're going to score that and give it a certain number of simple function points based on the fact that it's an elementary process. And we don't necessarily know up front whether it's going to be external referenced only data or whether it's data that we're going to be maintaining, and we don't know the structure. Oh my gosh, Simple Function Point says, hey, look, if it's a logical data file, we're going to count it. It doesn't matter if it's internal or external. We don't care if it's low, average, high. We're simply going to give it a certain number of simple function points. And this has been proven in research to be effective. And we've done a lot of work at the Department of Homeland Security in particular to do regression and do comparisons between an ifpug high-level count, a SiSE count, which I'll get into in a minute, or a simple function point count based on some of the things we've been talking about. So SiSE is based on simple function points, or SFP. International Function Point Users Group, SFP version 2.1. It was originally developed by Dr. Roberto Melli, who is actually now on the ifpug board, and Italian researchers, and released as version 1.1. And simple function points simplifies the functional sizing by just categorizing two types of functions. Generic elementary processes, so it doesn't matter if it's an input or an output or a query. And logical files, it doesn't matter if it's internal or external. So on the left-hand matrix here, I've got the ifpug, or the International Function Point Users Group components, external inputs, outputs, queries, internal logical files, external interface files, and their points, their function points, whether they're low or average or high, going through the full analysis of ifpug. SiSE, which is based on simple function points, simply looks at transactional functions, things like creates, updates, deletes, reports, reads. Each of those is given a score of 4.6 simple function points. Now you can see if you take a look at inputs, outputs, and queries on the left-hand matrix, it ranges between 3 function points to 7 function points. Well, the simple function point method says, you know what? We've regressed this, and on average, a transaction should be worth 4.6. So we're not going to go through the effort of pretending we know what it is, especially early on. We're just going to score each of these as 4.6 simple function points. And in terms of logical entities, you can see that from a if plug on the left-hand side component, it ranges from 5 as a low complexity external interface file up to a high of 15. Well, going through the research that they did, a logical data group, each persistent standalone entity, all of those save as will be worth 7 function points. Just makes it so much simpler. And what SiSE does is we took 140 verb keywords, and they, together with their team, said, you know what? Let's standardize and let's look at the patterns that are created from verb keywords. So as I said back here on the previous slide, things like we've got creates, updates, deletes, reports, and reads, those types of things are each going to be worth 4.6 function points. The research team took it and said, okay, let's take a look at all of the words that are really, really, really common in all of the past programs that we've done. And let's break those down. When you see the word create, what does that actually manifest itself into in actual software? When you see the word update, what is that really doing? When you see the word delete in a functional user requirement, what does that turn into? So those verbs, 140 different verbs, were analyzed and patterns were presented. So on the right-hand side, this is a sample of the SiSE template of the verb keywords. So an example verb keyword of create actually ends up being 2 transactions and 1 save. So if we take, to get the simple function point total for a create is 16.2, and that's based on adding up the number of transactions, multiplying that by 4.6 as is shown by the equation at the bottom, plus 7 times the sum of the data. So if you see the word create as a verb keyword in a requirement, and it truly is going to create a new data record, we can say that's going to translate into about 16.2 simple function points. Then we've got the word appeal. Okay, what does an appeal mean? An appeal means we're going to be updating a record that already exists. So that constitutes a single type of transaction worth 4.6 simple function points. The word cancel. The word cancel updates a record. So we've said, okay, that transactional function is just a single one. And we've got variations all throughout, as I'll show you in a minute. So on the left-hand side here, I've got a sample set of functional requirements that would come from a concept of operations. And there's a bunch of them listed. And we just took the 3 that we translated in. We've got something that says create user accounts for school officials. Okay, if I record that, I put the verb keyword create as the active verb. That's going to say, okay, that's 16.2 simple function points. Go on. So then submit. Submit is a verb keyword, and that would translate into a certain number of points. So what we did is went through a whole ton of programs, analyzed them, said, what are the most commonly occurring verb keywords, and what are their synonyms? Threw that into a template to generate very quickly at a high level the simple function point estimate. So the SiSE template of verb keywords and synonyms. The verb keywords equate to an established pattern of functions. So here's just an excerpt below. We've got things like accept. Accept, it follows the verb keyword pattern of create, where we've got 2 transactions and 1 data store. What is that similar to? Well, we analyzed it and said it's similar to granting or allowing. Now you may say, well, all grant does is updates a status. So it's really not a true create. So you would not want to associate necessarily grant with that same keyword. You still have to do some analysis on it. So we've got the word activate, we've got add, adjust, alert, allocate. All of these were analyzed and looked at in terms of the patterns that they represent. So there's an established pattern of functions. Simple function point values were assigned to each of the verb keywords in this lexicon. And synonyms for the verb keywords, as you can see on the right-hand side, expand the lexicon to over 400 different types of verbs that typically can occur. So it's pretty interesting. When I saw this, I actually thought about this, and I'm dating myself. About 25 years ago, I was working with a client, and we said, you know what? Why don't we do a high-level estimates of verb keywords and put them into a catalog? And at the time, it was really novel, so I was really excited to get involved in this team, because this was the type of work that they were doing now 25 years later. So the time has come. So in the SiSE handbook, it talks about, what are estimates? What are the things that we need to be looking for? How do you figure out the purposes and scope for an estimate? And it really focuses on 3 steps of estimating: determining the functional size, finding the throughput so that we can estimate the effort, and then taking a look and adjusting your size estimate for growth and uncertainty. So those are the 3 main areas. Within the SiSE handbook, we came up with a case study, and it's called weather. So weather is based on about 8 different sets of functional requirements. So here's how the verb keyword template works. So number 1, first thing you do is you drop in your requirements. So you take them from a requirements document or a ConOps or a backlog of user stories or whatever, and you drop it into the requirements spreadsheet. So everything else would be blank except for column A and column B. Then what we do is we have verb 1, 2, and 3, up to 3 verb keywords for a single requirement. And then we've also got some progress reporting where you can start taking a look and putting in the month, the calendar year, and the program increment, which I'll show you in a minute. So the first one was create a user account for all members of the public. Well, this is really part of maintaining an overall user account. So we didn't count this separately. So this was not a standalone user requirement. So we didn't generate a verb keyword for this. So number 2 says, and now it is part of something that comes below. So that's why it's part of number 4. So we didn't select a specific verb keyword for this. So number 2 says receive custom alerts to the user smartphone. Okay, we highlighted the word alert. Alert is one of our verb keywords. We type that into verb number 1, and you'll see that in the next column, it generated 4.6 simple function points. Okay, then we can receive custom alerts via email. So again, that's an alert. It generated 4.6 simple function points. So now we're up to 9.2. Now we can maintain user accounts. Well, maintain, from the verb keyword, the pattern was create, read, update, delete, plus a data store. So we've entered the verb keyword maintain into verb 1, and it generated those 4 transactional functions and 1 data function. So 4 times 4.6 plus 1 times 7 generates our verb keyword response of 25.4 simple function points. So the next one says the target solutions shall have security measures in place to manage the data access. Well, that's really a non-functional requirement of security and governance. So we would be allocating and looking at that separately. Now, we could have counted a create, read, update, delete, and a security data store. That's a possibility, but we don't know that. We just know that we need some sort of generic security. So we didn't count that as a functional. Then we've got the weather UI should be updated to display. Now, notice the word updated. That says the weather UI should be updated. That's not a functionality that the system will perform. The functionality is to display the latest weather information for a specified geographical region, and then the user can search for valid specific regions. So the two salient keywords are display and search. So we entered that into verb 1, display, and verb 2 as search, and you'll notice that it generates a certain number of function points, of simple function points. Now, if we enter a verb keyword that generates 0 in the simple function point columns, then we know it's not a verb keyword, and we need to go to our synonyms list on the protected sheet and select out the most salient or most appropriate verb keyword. So very quickly we can come up with, and we can have people who are business analysts who know the types of functions that are going on, but they're not experts by any means in function points, nor do they need to be. The purpose of putting this together is to come up with an estimated floor plan size of the functional, product backlog. And very quickly and easily, we can generate this and then use it in with our cost estimating equations. So Agile software development cost estimating, once we've got our size in a standard unit of measure that quantifies our size and the complexity of a software, then we need to take a look at what's the throughput. And throughput is the effectiveness of a development team to output the product as measured by a rate term. So things like hours per function point or dollars per function point, something like that. And in the simplest case, if we are doing analogy, in other words, finding a similar program in our historical, as long as it is within a similar size range, we can assume a linear relationship. Now remember back on an early slide, I said effort is size to an exponent times the throughput. That exponent can range anywhere from about a 0.97 up to a 1.23, depending on where you are and what type of software. But if we're taking a look purely at similar size, then our throughput that we get from a similar sized historical project can be used as an analogy to estimate the effort for this particular program that we're estimating today. So again, we start out with doing a high-level approximation of our user stories or our sprint backlog or our program backlog, and we size that. We then take a look at our historical throughput for similar sized, and then we can use those two together to create the time or the amount of effort, not the time, the number of hours of effort to create the final product. What is it going to take in terms of labor effort? And we can multiply the two together and get a high-level idea of how much effort is going to be involved. And from there, using labor rates, we can estimate the cost. And from effort, we can estimate the schedule. So throughput, Agile team throughput is based on many different factors, including things like the team composition and the experience, the requirements complexity, the coding language. Again, that's all dependencies. And the strategy for developing throughput estimates is early in the program, we're going to use rates from an analogous component program and or readily available commercial data. So we may have commercial estimating tools. We may take our SiSE estimated size and put it into a commercial estimating tool as the software size. And that works as well. Research has typically found values that range anywhere from 10 to 40 function points per person month. And we'd adjust these up or down based on team experience, the amount of non-functional work, the amount of complexity of having to look at things like performance and multiple platforms and things like that, and the type of project. And over time, we can update these based on actual team throughput rates. So what can we do when we've got a SiSE estimate? We can forecast the duration of a project. We can estimate the number of resources that might be required. We can do some Agile sprint planning, and we can use function points or simple function points as part of that. That's not to say you're going to abandon your velocity-based or your story point-based. but it gives you an additional little measure in your toolkit that we can start taking a look at. We can start reviewing vendor proposals on the basis of what was the functional size that they may have proposed versus the one that we came up with. And we can start taking a look at tracking some of the progress. These are all important things. And this is an example of one of the progress tracking charts. This is actually the fourth step in actually doing this. And some of the pieces on the SiSE template will allow you to actually go forward and project into the future and plot these things. So that all comes with the SiSE template. So in summary, and I know I'm going very quickly over a lot of different information, SiSE just, to me, is a game changer. It's a way of being able to embrace functional sizing, which is a proven way of being able to size software, without having to have a lot of training, a lot of analysis, a lot of working with, oh, is this an average, low, high, input, output query? You don't need that. It's a way of being able to, in a systematic way, go through a high-level product backlog, assign the verb keywords, and come up with a quantified estimate. Now, if you look closely at the first box that I've got outlined here, this is our SiSE template, and there's a lot of different pieces on it. So along the bottom tabs, we've got the template support, which just gives you who do you need to call. If it doesn't work, what do you need to, who do you need to call for revisions, or if you've got suggestions, because this is a work in progress. We've got an SIFP summary, which is the first box that's actually listed there. And that gives our program name, our name of the analyst that actually did this SiSE estimate, the date. We've got our simple function point additions. We've got a sheet that gives us our requirements, which is the sheet on the right. We have an interface sheet where we actually record our interfaces, our two-way interfaces with other systems separately. And those get multiplied by 16.2 simple function points. So rather than putting interfaces on our regular requirement sheet where they get lost, we put them and record them on an interface separate sheet, and they get generated. So we end up with a total simple function point number. We can then adjust that simple function point number by 4 or 5 different types of growth, which will give us a multiplier and generate a growth adjusted estimate. Now, the other tabs that are in here, you'll notice that number 1 is the SIFP requirements estimate, which is the spreadsheet shown on the right. There's a simple function point interface estimate, and that's where you list all your interfaces, add them up, and the template will generate the simple function point size. The red one that's listed here is the protected verb keyword sheet, so that you can go in and look up verb keywords or look up their synonyms so that you know what to put into those columns for verb 1, 2, or 3. And then there are 2 different types of plots that can be produced. Now, one of them, I have to give you a warning. The first one, which is the SIFP plot, does not take into account the interfaces, and it does not take into account the growth. So the plot that is produced is purely based on your requirements without your interfaces. So that's a work in progress. And we realized after we released this that it typically needs to be cleaned up. So that, as I mentioned, this is a kind of a beta work in progress. The one on the right, which is the project tracking sheet, you actually hand enter dates and things like that. And you hand enter the simple function point numbers. So you can put in your growth adjusted simple function point numbers. So that project tracking chart is very good and actually will generate a plot for you. So one of the things that has been learned so far, and as I mentioned, this is really only in release 1.1. It was released to the joint cost estimating group within the Department of Homeland Security and the 13 related federal agencies. But as I mentioned, this is open source and it's available to anyone, anywhere in the world. It is not specific to Department of Homeland Security. It is absolutely just open source. So it provides benefits to an Agile program. It provides faster, more reliable, and a repeated process to provide credible estimates. It's tied to high-level program requirements. It can be performed early in the program's life cycle. And tracking the functional delivery provides insight into overall program progress. It plans appropriately for program schedule and resources, allows issues to be identified early, and it's an absolute work in progress. Now, this is an open source. I'm not speaking on at all on behalf of the Department of Homeland Security. I'm speaking on behalf of an open source, readily available method that can help you do functional sizing early and quick. And thank you for attending. This is the overall development team that I've been working with. And if you need to contact any of us, my information's on at the beginning. And thank you for participating and listening. I know that we're finishing a little bit early, Susan, and I just want to say thank you to the great IT professional. There will also be a webinar available from, I believe, all four of us with IFPUG in March of 2022, that if you're interested, it will be a free webinar that you can attend, and it will expand on the information I presented here. This was purely to be an introduction to some of the great work that the entire team and the research community has been doing to provide you with an introduction to taking simple function points and expanding that into some very useful information that may help you when you're trying to come up with better, more reasonable, and realistic estimates. So back to you, Susan.
Could we please get a copy of the slide deck for further research? And that we leave up to Carol. So I'll leave that to you, Carol, at your discretion.
Yeah, if I'm going to put my email in the chat box, if anybody wants to send me, and I'm putting in an alternate email address as well, which is on Gmail. So you can do it. You can send me dekkers@qualityplustech.com or caroldekkers@gmail.com. Either one works.
Question: how accurate has the method been? What has been the variance?
That's a really interesting question, because there is research being done to come up with CERs, or cost estimating relationship equations, where we found we've done 3 counts or 3 estimates. We've done it using pure simple function points. We've done it using high-level IFPUG function points, which is taking all average. And then we've done it with SiSE. And the results come back almost exactly the same. And what's actually really interesting is that we have on our team, one person will do the SiSE estimate. And then I go through as a certified function point specialist fellow, and I review it, and I actually do a simple function point count and a IFPUG all average function point count. And what comes up is a question of, oh, did we analyze something that actually should have been a non-functional requirement? So they actually come very, very close. There's sometimes that the verb lexicon did not have the verb that we needed. We have not gone back and done detailed functional requirement breakdowns to see how close simple function points or IFPUG high level or SiSE will come to the actual implemented. But there's an issue with that too, because throughout a program, there are changes that happen. And so we would be comparing our initial estimate to an actual implementation, and we'd have to trace back and see which requirements actually changed as you go through. But following the kind of cone of uncertainty, SiSE or simple function points or IFPUG high level provide you with some really, really solid high-level estimates. There's also 2 commercial products that are coming out, that have come out. One is called Cadence by Log Apps, and the other one is called Scope Master by the same name company out of Britain. and they will take verb keywords and analyze them and come up with a similar type of approach. But there's a couple of things that you really need to know about. We've outlined those in the SiSE handbook. And one of them is that you have to use functional user requirements. You can't just take the JIRA output, which say, you know, as a user or as a developer or as a tester or as this. The user stories can be all over the map. And oftentimes we have to first distill those so-called user stories into bona fide functional user requirements to say, what does the software do? Because when you're in the middle of a project, oh my gosh, the JIRA stuff is all over the map. There doesn't seem to be any sort of rhyme or reason, even into how oftentimes user stories are written.
Could you publish links to the SiSE handbook and Excel templates and other CAD Department Homeland Security artifacts that support your presentation? Thank you for the overview. I hope that made sense.
I'm not sure if we've got it published yet on a public link or not. I'm going to check with my my team and find out. But barring that, I'm going to also double check 100% that I can send out the handbook and the template to anybody that sends me an email. But I'm 99.9% sure I can without a problem.
And we do want to thank you, Carol, so much for presenting with us today.
Hey, thank you, Susan. Thanks everybody who attended.